Hello everyone, welcome back. So today our session is subnetting. What is subnetting and why we need subnetting and how to do subnetting? The first we need to understand this. But before understanding this, the first I will repeat one more time in class A, class B, class C. So in class A, as we discussed in our in IP address class, in class A, one network portion and three host portions. In class B, two network portions, two host portions. In class C, three network portions, one host portion. These are the default network portions and host portions, not fixed. In class A, we have one network portion and three host portions. In class B, we have two network portions and two host portions. In class C, three network portions and one host portion. One network portion equal 8 bits. Here, three host portions equal 24 host bits. In the class B, 16 network bits, 16 host bits. In the class C, 24 network bits and 8 host bits. So as per this, class A provides 1 crore 67 lakhs 77,216 IPs to power of 24. In class B, 8 plus 8, 16, right? 16 host bits are there. So 2 power of 16 equal 65,536. In class C, we have only 8 host bits. So 2 power of 8 equal to 56 IPs. Class C network provides only 256 IPs. Class B network provides 65,536. Class A network provides 1 crore 67 lakhs 77,216 IPs for each network. Right. So now, first here in the class C provides 256 IPs for every network. So for example, 192.168.1.0, this is one network in class C. So here, this is network portion, this is network portion, this is network portion, this is the host portion. Host portion always start from 0 and ends with 255. So 1.0 like 1.1, 1.2, 1.3 like that up to 1.255. This is one network. And if we change any number in the first portion, second portion, third portion, that network would be different network, right? For example, 192.168.2.0. So this network is also start from 2.0 and 2.1, 2.2, 2.3, 2.4 and 2.255. This is another network in class C. And in class, okay, I will take one more network, 192.168.3.0, 3.1, 3.2, 3.3, 3.4, 3.5, like that, up to 3.255. This is the third network in class C. So here, every network provides 256 IPs. Here we have a 256 IPs, here we have a 256 IPs, here also we have a 256 IPs. So this network has 256 IPs. This network has also 256 IPs. This network has also 256 IPs. If we take any network in class C, that network provides 256 IPs. But here, in every network, first IP and last IP are reserved. First IP is network ID. Last IP is broadcast IP or broadcast ID. First IP is network ID. Last IP is broadcast ID. For example, if you take this network 192.168.1.0 network, 1.0 is the network ID, 1.255 is the broadcast ID. So 1.1 to 1.254 or 1.1 to 1.254 are valid IPs. Remember this point. Valid IP means we can use these IPs. We can assign these IPs to systems. 1.0 and 1.255 cannot be assigned to any device. Same way in the 2.0 network also, 2.0 is network ID, 2.255 is broadcast ID. 2.1 to 2.254 are valid IPs. Valid IPs, 2.1 to 2.254. In here, in third network also, the first IP network ID, the last IP broadcast ID. So 3.1 to 3.254 are valid IPs. These IPs are valid IPs. So in every network we have two IPs reserved. One is a network ID, one is a broadcast ID. So we cannot use these two IPs. So Class C network provides 254 IPs only. So -2. Here also -2. Here also -2. So in Class A, in every network, we will get 1,67,77,201 4 IPs. In Class B, we will get 65,534 only each network. In Class C, we will get 254 IPs only. Right? First, remember these points, very, very important. In every network, we have network ID and broadcast ID. The network ID is used to identify the network. That's it. The broadcast ID is used to send the data, all the systems in that network. But broadcast IP is actually used by systems or protocols. Okay. The next thing is we need to understand subnet mask. In Class A, for Class A, the default subnet mask is 255.0.0.0. For Class B, default subnet mask is 255.255.0.0. For Class C, the default subnet mask is 255.255.255.0. These are the default subnet masks. Why here in Class A 255.0.0.0? Because in Class A, we have only one network portion and 3 host portions. In Class B, we have 2 network portions. That's why the mask is 255.255.0.0. In Class C, default subnet mask is 255.255.250.0. Why? Because in the Class C, we have 3 network portions. What is the purpose of this subnet mask? The subnet mask purpose is to identify the network bits and host bits in IP address. Remember this point, very, very important. The subnet mask is used to identify the network bits and host bits in IP address. Without subnet mask, we cannot identify the network bits and host bits in IP address. For example, I have 192.168.1.0. or 1.2, 1.3, whatever it may be. This is one IP address. So how can you identify here how many network bits and how many host bits are there? But default is 255.255.255.0. That is the default. Okay. Whenever you see this number 192 is a class C IP address. We can say like it is a class C IP address. Here we have a 24 default network bits. The 24 default. 24 means what? Three portions, right? First portion, second portion, third portion. So this is the network portion. This is the network portion. This is the network portion. Means these bits, okay, in the binary, right? 192 means what? 192 means 1100000000. This is the 192. So these bits are considered as a network bits. That is the purpose of the 255. 255 means what? The first 8 bits. Okay, and next second one is what? 168, right? 168 means what? 128 plus 32 plus 8. 4, 2, 1. Next to 1. 1 is what? 000000001. This is the, so these 8 bits, these 8 bits are what? Network bits. But how to say these are the network bits? So right, with the help of subnet mask. So here we will configure 255.255.255.0. So these 255 tells us, so these 8 bits are network bits. These 255 tells us these 8 bits are network bits. And 255 tells these 8 bits are network bits. And 0 means here there is no any network bit. All bits are host bits. This value is very, very important. Without subnet mask, we cannot identify the network bits and host bits in IP address. This is default subnet mask for class C. So these are the important things before understanding subnetting. So first we should know these clearly. Number of network portions, number of host portions. What is the network ID? What is the broadcast ID? And what is the purpose of the subnet mask? Subnet mask purpose is just to identify the network bits and host bits in IP address. Subnet mask is different, subnetting is different. Both are not same. Subnet mask just to identify the network bits and host bits in IP address. But now we will discuss what is subnetting. So why subnetting is required? Without subnetting, what happened? Okay. Now I will give you one example. For example, I have 3 departments. Department A, Department B, Department C. In Department A, there are 50 users, 50 employees. In Department B, there are 30 users, means 30 employees. And Department C, there are 10 users, 10 employees. These 3 different departments, and I want to connect these 3 in different networks. So for Department A, we require one network, Department B require one network, Department C require one network. So in Department A, we have only 50 users, right? 50 users means which class is better? So in a class C, sorry, in class A, we have 1,67,77,216 IPs for each network. In class B, 65,536 IPs for each network. For class C, 256 IPs are there, or for each network, right? Here, which class is the best one? So here we have only 50 IPs, right? 50 users. 50 IPs users means 50 IPs. So we will definitely use class C only because class is enough. So now for Department A, I will take one network. Network is 192.168.1.0 like that. For Department B, I will take other network. Same class, I will take different network, 2.0 like that. And for Department C, I will take another network, 192.168.3.0. 192.168.1.0. For Department A, what is the network? 192.168.1.0. So what is the range of this network? This network range is 1.0 to 1.255. Here also 2.0 to 2.255. Here also we have 3.0 to 3.255. So here every network we have 254 IPs. Here 254 IPs. Here also we have 254 IPs. Here also we have 254 valid IPs. Only 254 because the first IP is network ID, last IP is broadcast ID. So we have only 254 IPs. But actual, what is our requirement? Only 50. There are 50 users only, right? 50 users means only 50 IPs we required. But network provides how many IPs? 254 IPs. So here what happened? We have only 50 computers. So, but this network provides 254 IPs. So here we will lose 254 IPs. For department A, we will lose 254 IPs. 254 IPs. For department B, we have only 30 users. Means we required only 30 IPs. But network provides 254 IPs. 254 minus 30, 224. We need to lose 224 IPs. For department C, only 10 users means we require only 10 IPs, but network provides 254 IPs. 254 minus 10, 244 IPs. So here we lost 244. So here total 6 more than 600 IPs we will lose. This is the problem with IPs because we should not waste our IPs because we have a limited IPs in the private IPs. In class A, we have only 10.0.0.02, 10.255.255.255. In class B, 172.16.0.02, 172.31.255.255. This is the class B private IPs. In class C, 192.168.0.02, 192.168.255.255. These are the private IPs. We should not waste IPs here. For example, if you want to use a class A network, I have 3 departments. How can you use here? Here we have only one network, right? 10 series. Okay, this network provides how many IPs? 1,67,77,216. Okay, but these all IPs are same network. But here I have 3 departments. If you want to use class A, so this 10 series we will use for department A. For department B, department C, what? We can't, right? Same way in the class here 192.168 series. So how many networks we will get here? 0.0, 1.0, 2.0, 3.0 up to 1.0, 2.0, 3.0 up to 255.0 network, right? Total 256 networks, private IPs. So for example, if we have a 500 departments, we can't use private IPs. We don't have this much of networks in class C. The class C we have only private IPs are what? 192.1.0.02, 255.255 only, right? So which means we can use 0.02, 255.0. If we have more departments, can't use. That's why here we should not waste our IPs. Even though these are private IPs, even though these are the free of cost, you should not waste our IPs. So without wasting, if you want to use IPs, we will use subnetting. What? We will use subnetting. 2 seconds. So we should not waste our IPs. So we should use these IPs efficiently. Right? So now I will show you how to do subnetting. First understand what is subnetting, right? First understand what is subnetting. Subnetting is nothing but dividing a single network into multiple networks. Dividing a single network into multiple networks. dividing a single network into multiple networks. Here, dividing a single network into multiple networks. Subnetting means converting host bits into network bits. Remember this point, very, very important. Subnetting is nothing but converting host bits into network bits. We cannot convert network bits into host bits. We cannot convert network bits into host bits. The third point is, if requirement is host, we have to borrow bits from right to left in host portion. If requirement is host, we have to borrow bits from right to left in the host portion. If requirement host means nothing but IPs, number of IPs. Like just now we discussed, right? Department A required 50 IPs, Department B required 30 IPs, Department C required 10 IPs, like that, right? So this is host requirement. And if requirement is networks, we have to borrow bits from left to right in host portion. Left to right in host portion. Remember these 2 points, very, very important. If requirement is host, we have to borrow bits from right side to left side in the host portion only. If requirement is networks, we have to borrow bits from left to right in host portion. In the host portion only. Subnetting is nothing but converting host bits into network bits. Remember this point. Keep in mind this point. Very, very important. In the subnetting, we will always convert host bits into network bits. We cannot convert network bits into host bits. We can't do anything on network portions. Next, advantages. What are the advantages of subnetting? Reduce the wastage of IPs and reduce the broadcast traffic. Reduce the broadcast traffic means we already discussed ARP protocol. We already discussed DORA process. So in the ARP, what happened? Whenever a PC needs to find out destination PC MAC address, if source PC doesn't know destination PC MAC address, right? PC sends ARP request. So ARP request is the broadcast message. Means remaining all computers receive this broadcast message. For example, if you have a 500 networks in your network, if any one PC sends ARP request, remaining 499 PCs will be received. Okay, if one PC does broadcasting, no problem. At the same time, if 20 systems or 30 systems or 40 systems, number of computers at the same time, if number of computers generate ARP request, what happen? Every PC receives the broadcast traffic number of times. This is the problem. This broadcast traffic consume more CPU and memory usage in every system. At the same time, it will reduce the network performance. Right? So if your network is very small, very limited, your network, what happen here? Only those systems will only receive the broadcast traffic. It will not impact to all other systems. Right? This is also one advantage of doing subnetting. And DORA process also, right? DORA process is a different story. This is here also we have a broadcast traffic, right? Okay, just leave it this one. Okay, next point, easy administration. Easy administration. If your network is very small and if we get any issue, we can easily find out the issue and we can easily resolve the issue. So these are the main advantages of subnetting. The main advantage is here, reduce the wastage of IPs. Reduce the wastage of IPs. So in the next session, I will show you how to do subnetting.